implement it in R, the R codes for time series, and I have also shared how to apply XGBoost, extreme gradient boosting for time series analysis. Okay, any questions? Any questions from the previous class before I start today's class? Any questions, folks? Not only previous class, from the last classes as well. Okay, if you don't have anything, before I end last class, I think Kriti asked me that question regarding data cleaning. So today I am going to start with data cleaning first. And the first 15-20 minutes I shall spend on data cleaning, and then I shall move to today's topic, retail analytics. So have you ever got any exposure to data cleaning? Have you tried your hand with any kind of model development and faced this problem that the data is messy? How to impute the missing data? How to detect outlier? Have you faced any problem at past? Do you have any experience? And of course, that's the reason I'm asking this question, because there is a significant or gulf of difference between the traditional way of machine value imputation and what's been done in today's times in the current data. So do you have any experience? Have you ever done any kind of data cleaning work at past?
No, sir.
Okay, okay. And you understand the meaning of the word data cleaning, right? That part you understand, right?
Yes, sir.
Perfect, perfect. So what I shall do in that case, I shall also walk you through that how at past the data used to be cleaned and what's the modern methodology, analytics techniques, the deep learning techniques that have been used to clean the data. So these are the basic cleaning techniques that you must be cautious that there should not be any extra space in your column headings where it is the name of the variables are being stored. Select and treat all blank cells, that's the missing value part. Convert numbers stored as text into numbers. Sometimes it happens that, where it should be all numbers, you are finding the text data. So what to do with that? Remove the duplicates, and these duplicates can happen in many ways. Like that can be duplicate entry. If there is a duplicate entry, there can be name matching algorithms. Those who are from the computer science background, they must be knowing there are different name matching algorithms you must have done in your very first few classes. The name matching algorithms will help you to figure out the duplicates. It should highlight the errors. Change text to lower, upper, proper cases, spell check, delete all formatting. So these are the kind of basic cleaning techniques. Most of the things are very, standard, like remove duplicates. These are kind of very standard computer science algorithms, which has got more of computer science than of data science. And I shall focus primarily on the data science techniques here, which includes the missing value imputation and the outlier detection. So let's start with the missing value imputation. So what happens, in many of the most data sets that we get, even in the industries which are very renowned for their good quality data, say for example banking and financial, even they have a lot of missing data, right? So that creates a kind of serious problem for the data scientists, because with the missing data you cannot really do much. So what we do in that case, traditionally we used to have, when we didn't have this kind of techniques, the old age techniques were imputation through the mean, median modes. Uh, Say for example, you have got a series like 3, 4, 5, 6, 7, and this kind of numbers across a column, and then there are a few values missing. And traditionally, all these mean, median, mode are being used. What I'm looking for is that this PDF becomes a static image. Let me open the kind of dynamic image here through the PPT. So you will understand how this KNN works in case of a dynamic image. Yeah. Yep. Allow the entry, month. Yeah. So it's a kind of dynamic image which gets static in PDF. So what happens? What happens? In current times, we don't use the traditional mean, median, mode imputation. Those are they cannot do justice. Simply, they are really kind of uh, very rudimentary. They cannot do justice to the different kind of patterns that we see in the data sets, which are pretty sensitive towards the missing data. So if you just impute it to the mean, median, mode, then the entire essence of the data, the nuances, the finer nuances of the variations in the data gets lost if these are just being imputed. So how does KNN work, right? How does KNN work? But I'm just going to discuss that how does KNN work in the context of missing data imputation. Otherwise, we discussed how does KNN work in the context of churn analytics. In the first class, I presented the concept. In the second class, I have elaborated and discussed that concept, and you have the text for that. So what happens is that the values, say for example, I'm looking at, let me take a very simple example, sales and price. There are two columns, and the objective is to predict sales based on price. And this few word is important because if it is more than 30%, it becomes very difficult. It is not safe to impute, but less than 30% is, yeah, still manageable. Say for example, some amount of data in the sales column is missing, and you know the kind of corresponding prices of those missing sales value. So what you can do, a simple thing, you can look at all those data points that were corresponding to those sales figures at different price points, and then you can actually uh, impute that missing value of sales from your existing price points. So that's how KNN works. The KDD tree also works. So that's one of the more sophisticated measures of imputing the k nearest neighbor. There is another sophisticated method which is mostly being used, is called the MICE, or the multivariate imputation by chained equation. So this type of imputation works by filling the missing data multiple times. So multiple iterations take place, and with multiple iterations we impute. So it's a kind of separate modeling exercise, in fact, for missing value imputation. Say for example, let me take the same instance of sales and price. So from the existing sales and price data, you can create an equation, right? For all those data where it is non-missing values, you can create an equation. So you have got an equation like y equals to mx plus c, or sales equals to m into price plus constant. Then you have got some price values and the sales is missing. So you can even simply impute such missing values of sales from that equation. Am I making sense with this logic or not? Tell me frankly, am I making sense or not?
So, when, so whenever we have a huge data, suppose we're getting a big data from any company, then how will we clean this data?
As I mentioned, it won't be wise. It won't be wise to touch. First of all, if you look at the column wise, data is kind of big thing. The entire data set, that's a big thing. Uh, when you will do such kind of exercise, the first thing is that you should check what percentage of data is missing. Suppose there are 10 rows. If it is 30% or below 30%, it's still manageable. But if it is more than 30%, it becomes very risky to do it. Not very advisable unless compelled by the business, unless business feels that that is sacrosanct. that you cannot eliminate from your analysis. So first you check what is the level or what is the amount of missing value. Once you are sure, yes, this is something less than 30% manageable, then what to do? The traditional way, which is not so good, is the mean median mode imputation. I'm not talking about that. So traditionally, they will take the column and then they will compute the mean median mode, and then they will replace those blank cells with the mean median mode. That's not the best way. So what's the best way? The best way is to create the models. Models can be k-nearest neighbors. Models can be your chained equation. So how does that work? That example I gave, and follow it minutely. And if you don't understand, ask me. Say for the sake of simplicity, I'm taking two sales price or age income, something like that, just to make it very simple. And you know that there is some amount of dependency, like income is dependent on age or sales is dependent on price. So you are supposed to predict income based on age or supposed to predict sales based on price, right? That's the kind of problem statement you are having. For example, now you have got some amount of sales data missing or some amount of income data missing. Say 20% of the sales data missing or 20% of income data missing. Now you have got 80% of the data with you, correct? 80% of the sales data, 80% of income data, along with corresponding age data, or 80% of sales data, along with corresponding price data is with you. So if such data exists, then you can easily create an equation, develop a model between the two, and then you can predict the missing values from the existing price value with that model. Am I making sense?
Yes, sir.
Yes,
Any
sir.
of any of you who has not understood the strategy, tell me very frankly. Though don't take my words literally. I'm just philosophizing in kind of through a storytelling. I'm just telling you. Actually, when you
Sir, can you repeat again?
sure, I guess somebody is not on mute. Sure, let me repeat. Or why doesn't it happen in this way? I think some of you said that they have understood. Why don't you repeat it? And then if you commit a mistake, I can always rectify that. That would be a kind of revision. Couple of gentlemen said that they understood. So could you please come and share your understanding? Feel free, feel absolutely free. May I know the names who said that I understood? Why are you feeling shy? It's absolutely fine. Worst case scenario, you will not commit outright. That's fine. Sky will not fall. Anyway, let me repeat it. So what I mentioned is that first of all, you look at the respective columns. In the respective columns, is it a massive data missing or a reasonably manageable data missing? That's the first thing. If it is really huge, it becomes very risky to impute. That is not something one should try. But if you feel that yes, this is something still manageable, less than 30%, I can pretty well make it a kind of complete data set with the imputed values. Then you can play with it in number of ways. So traditionally, they would have left it only with this mean imputation. But that is not something, of course, we do that thing still, but then there's a long way to go. So what we do is that I'm just trying to make you understand what is the philosophy of through a kind of story. What is the philosophy of missing value imputation in today's world? What we do is that we try to predict the missing value through the adjoining values. What is the adjoining? It means the corresponding values. Say, as I gave the example, sales price, sales is missing. You have got the price values. Or say income age, you have got the age values, right? To predict income. So how do you do it? So you can always create some kind of distribution of the existing ones, like say sales distribution you can have. And then you can feed the values through the sales distribution that where it should, how to connect the dots to create the right distribution. Or what you can do is that wherever there is a kind of you can develop a model like with the existing data of sales and price or age and income, and then wherever you will find that you can predict through an equation from the existing data. So if you create an equation y equals mx plus c or sales equals to m into price plus constant, out of that existing data you have to just feed it there. So that can be done in several ways. So that is again not the best way. There are different more sophisticated ways. Because that might overfit the model once you will develop. So that's why k-nearest neighbor is another one. So what you will see that okay, if sales is say for example 30, and then price is for example 8. I'm just saying. Now you have got a price point of 10, and the sales is missing. What is the nearest sales figure you are getting? That's how the k-nearest neighbor work. It also works in a kind of Bayesian relationship. That's also possible with kind of conditional probability. You can say that this is what the missing value would be. So there is no one best way. There are multiple ways through which to do it. But what I want to say here is that you should not just impute it with the mean median mode. You try multiple approaches. It can be k-nearest neighbor, it can be Bayesian, it can be the MICE, which is the multivariate imputation by chained equation. So you are doing a kind of chain equation, you are doing a kind of mean imputation, simple first, and then age, you are putting it back to NA. Then you are doing a kind of Bayesian linear regression, where age is a function of income and gender. And then you are doing a linear regression to predict the age, then income back to NA. And then again, you are doing a linear regression with income is a function of age to gender. Then linear regression predicts the income. The same for the gender you do. So that's how the change equation goes. That's I always emphasize on the creativity part. So again, this is not the kind of standard rule. There is nothing. This is the kind of instance. This is an instance. This kind of representative one. But you have to play it in number of ways. But what is important is that don't just play it with a kind of mean median mode imputation. But that means what? Just leave it here. Oh, I have imputed it. No, that is not the best thing. You play it in multiple ways and see how best you can represent the real life scenario. Am I making sense to you? Am I making sense to you?
Yes, sir.
The lady who asked me the question, may I know your name? Who
Yes,
asked
sir.
me that?
Shweta.
Shweta, have I answered? Is it clear to you?
Yeah, sir.
Okay. So think it in this way. You have already learned multiple modeling techniques, right? It is logistic regression, it is the k-nearest neighbor, it is the different deep learning techniques. Of course, you know the regression even before my class. So think it in this way: how I can apply these statistical techniques, these machine learning techniques, in a creative way to impute the missing values, to clean the data. So there lies a lot of creativity. There lies, that's why not all data scientists, even if they're all trained with the same tools and techniques, they all know the same tools and techniques. The output varies. Just, I can give an example of cooking, for example. Even if the same ingredients are given, depending on the cook, the taste, the aroma, of the food really vary. The same thing here. Only difference is that in cooking, you can still have a kind of standard recipe. Here, it is not that it is not there. It is there. There, a recipe can always be formulated, but I refrain. I refrain from giving you a kind of standard recipe, because if I give that thing, then you will not search for something new, and that's very important. You know, that's how, as I gave the example of cooking, then I can give the example of, how you can become a chef from a regular cook. A lot of creativity is required. You have to think in a creative way and experiment, bring out the best. Yeah, that's how you can become a real good data scientist, if you play with the algorithms and see. So chain equation has been mentioned, but you see what are the best ways to create that chain with all the algorithms that you have learned. Okay, so with that, let me go to the next one, like imputation through the deep learning techniques. Again, what I discussed, like so yesterday or even previously, we discussed the long short-term memory or the gated recurring unit, the forms of recurrent neural networks. So if you get a kind of time series data and you are finding that some values are missing, so why don't you try? Why don't you try that? Assume that this is a kind of series, and then the missing data are something that you have to predict, right? The same thing that I have shown to you. Just assume that it's a kind of something that should be predicted, or if that falls at certain distribution, I have to predict the next steps in the distribution. Then this kind of different thinking will help you to impute the missing values in a creative way. That's what my point is. Am I making sense to all of you, what I'm saying? Am I making sense to all of you? Yes, no?
Yes, sir.
Perfect. May I know your name, please?
Shweta.
Yeah, thank you. And Kriti, you asked me this question yesterday. So do you think your question is getting answered? You want something else? Feel free to ask me.
So slightly I'm getting
Sorry, I'm not getting it. 1 second, repeat.
I'm getting to know the things, like I'm
Yeah,
trying to understand more and more.
yeah, yeah. That's what it should be ideally. If you claim you means anybody, even if I been in your position, I would have claimed that I have understood. I am still learning. Even I am still learning. After 20 years in this field, or 20, even more. I started statistics 50 years back, almost 25, 27, something like that. Yeah, still learning. So yeah, and this learning is kind of this learning is not of learning new knowledge. Of course, that is there, but more importantly, how you can apply that knowledge. Say, as I mentioned, you k-nearest neighbor could be applied for missing value imputation. You learned k-nearest neighbor earlier in the context of churn analytics, but that's the kind of new learning which you have to constantly do. Can I apply KNN here? Or the same example I gave you yesterday about lateral thinking, say survival analysis. I gave you the example that survival analysis started in the healthcare industry, where it was supposed to predict how long a patient will survive given a critical disease. Then that has been translated in the context of churn analytics. How long a customer will be with a company, or how long an employee will be with an organization. The same survival analysis can be extrapolated in the context of attribution modeling. What I was discussing yesterday, like when the person is going to convert, depending on the several clicks, views, impressions of the different websites and web ads. So click, non-click is a kind of binary dependent, whereas you have got another dependent variable, the duration. So yeah, so the same techniques can be applied multiple areas, and that you can always think, learn, relearn. Yeah, all those things are a part of life. Okay, now come to the next part. Outlier detection techniques. Traditionally, this has been done by something called box plots. I don't know whether you know it or not. We used to divide the data into multiple quartiles, like first, second, third, fourth, and anything which is beyond or outside this data set, we used to call it outlier, and then call it out. I'm not saying that approach is bad or wrong, but then currently that would have been very good had it been kind of small data. But with the advent of big data, when you have got multiple outliers, and each of these outliers, not each means don't think one, each here means that can be a small segment, that can be small segments. So when each of these outliers say different kind of stories, then it's very important. Then it's very important to understand what is that story behind it. And at that, in such scenarios, it's very important not to just say it, not to just say it, oh, this is the outlier. The story will come out. The story will come out if and only if you do a kind of cluster analysis. Am I audible to all of you?
Yes, sir.
Okay. So if you remember, while I was discussing the segmentation, I was discussing with you that how from the different variables within a cluster, the story can be, the characteristics can be understood. The characteristics of the cluster, the story can be created. Say within a particular cluster, how the different variables are distributed. See the different income, interest, all those things, how that can be distributed, how that with the distribution, the story can come out. The same thing is for the outlier, because for the outlier to take a decision, will you remove it, or will these outliers be treated within your analysis? So for that purpose, it's very important. It's very important to understand that what story is this outliers or this group of outliers saying to you. And so we follow currently isolation forest, a kind of decision tree, which very clearly, very clearly, speaks out the decision within that particular outlier sets, or a kind of DB scan, density-based spatial clustering applications with noise. That's another form of clustering technique, which will also tell you that okay, these are the kind of constituent components of the clusters, and if you study the characteristics of that cluster, the story will come out. Am I making sense or not? Tell me very frankly. Yes, no. Do you understand the meaning of the word outlier? First of all, I have not, again, my assumption was that you understand. I can be wrong in my assumption.
Yes, sir, we know outlier.
You know outlier. Perfect. Perfect. So let me repeat my story. What I said, that there is a very common way where we used to follow in the marketing research area, figuring out what is the kind of 4 quartiles and figuring out what is going beyond the quartiles. There can be 1 or 2 dot points here and there. And then we used to emit that or speak with the client. But currently in the area of big data, it is not 1 or 2 data points. There can be multiple sets here and there. So it's very important to understand the story behind those clusters, behind those outliers. And how can you understand the story? You can only understand the story if you look at how the variables are distributed within that cluster. You remember these words, variables are distributed. You remember those dashboards. Somebody asked me a question, why it is called disparate. So I then explained them when I was explaining the segmentation. I explained them, okay, look at the kind of interest this segment is paying, look at the income, and they're disparate to purchase. And then I created the story. That's the meaning of the word story. Am I making sense to you? Yes, no?
Yes, sir.
So the same story you have to find out from this set or the cluster of outliers. That why they are outliers. Should I consider them? Should I not consider them? To understand the story even better, this isolation forest can be created, which will create a kind of decision tree within those set of outliers, and will help you understanding this how they behave, why they are becoming outliers. So that why is this story important? Because take a decision. What decision? that should I eliminate them, omit them from my analysis, or should I incorporate them, include them in my analysis? So that story is very important. Without that story, one cannot, one should not uh, do it mechanically. Just okay, this outlier, let me eliminate, let me omit. Nothing like that. You have to discuss with the client. Maybe multiple meetings can be created just on the set of outliers. Maybe those outliers create very interesting stories, interesting opportunities for the clients. So, for example, very high value spenders can be an outlier. And so how are they behaving, what they're purchasing, what they're not purchasing? So a lot of story can come out when they're purchasing, why they are purchasing. All those stories can come out, even how they're purchasing, online, offline, how. So this clarity, this visibility is required while treating the outliers, and that visibility can come out if and only if you work with these modern techniques like DB scan, one of the clustering technique, or isolation forest. That story cannot come out with the traditional techniques. Am I making sense? Are you understanding, getting some sense, some flavor?
Yes, sir.
And I'm trying to make it as much in English story as possible, not intentionally diving deep into the mathematics part. Okay, so with that understanding of data cleaning, which we spent the first half an hour, next 45 minutes I shall dwell on the retail analytics part. Are you all clear why retail analytics is a part of sales and service? Have you all studied retail, first of all, because retail analytics is an offshoot of retail management. But have you studied retail management first? Has
No,
it been?
some of them
Yes.
have.
Sorry?
Some of them have.
Some of them. Okay. So just let me give you a very brief about retail service, and more importantly, why retail is a part of the sales and service analytics. So retail is a service, first of all. Why retail is a service? Because you are adding convenience to the customer, you are adding value to the customer, and of course, you are selling the products. You might sell the product, that is fine. But then the entire retail concept, the way you are taking it wholesale, and then you are adding convenience. Convenience means selling it at a customer's location. That becomes the kind of service in itself. And of course, within that, there can be products and services. Suppose if you are purchasing a packet of chips or a Coke, that can be a product. But when you are taking the gasoline from your nearest pump, that is a service. Or you are going to a movie hall, that's a kind of service. If you are going to play a golf, that's the kind of service you are taking from the golf club. Or even you are going to the bar or pub in the evening to hang out, that's the kind of service they're offering besides the product. So even in a restaurant, for that matter, so there is a food and service component, product and service component associated with it. So that's, I think, a very critical concept in retail management. You should be very clear about that why retail is considered as a part of a service, even if there's a product and services separately. With that understanding, of course, I shall dive much depth to it. Though I assumed it has been taught, but no worries. I shall highlight or focus on the important parts here. But before dive deep into all those details, I should not ask you. Let me rather tell you what is the most important part of retail. The most important part of retail is the location. If you read any books of retail, even if you Google it for that matter, you will find that if there are three most important things in retail, one should consider, the retailers should consider, and they will call it location, location, and location. Now, if I ask this question for a kind of free thinking across the class, so how will you take a decision on the location by applying the analytics or the modern technology? Any thoughts on that? Even if you don't know anything, but think creatively. Suppose you have to take a decision. You have to open a store or a chain of stores for that matter across metropolitan cities or even within a metropolitan. Say, for example, Delhi has got several pockets. Every pocket's behaviors are very different. So how will you understand that thing? How can you approach such a problem? Any solution framework that comes to your mind? I need not think from the algorithm perspective. When I'm saying or asking such questions, it is all about your critical thinking. How can you approach such a problem?
So geographic of area or chances of selling.
Of course, no doubt, but how will you map that? That's my question. How will you understand? Say you mentioned the geographical. Of course, geographical. When I said metropolitan cities or within that, it has to be geographical only. But how will you understand that? How will you collect the data? Because what I'm going to introduce with this question is something absolutely critical and the most modern thing that is happening in the industry.
So land price, I'm not sure.
No, but good that you are thinking. Yeah, but good, good proxy variable. These are all the proxy variables or the pseudo ones, but good one. Yeah, good try. May I know your name, please?
Sure.
Yeah, good one. Anything else that crossed your mind? Who all are there today? Eight folks are there. What's up in it? Okay. Yeah. Any of you? Just this is a kind of very open-ended questions. They're very open-ended question. Yeah. Nothing right or wrong. Go ahead. How will you solve such a problem? What? Yeah.
So,
Your name.
yeah, so
Yeah.
Vanessa
Go ahead.
said. So, like you said, if we take a location, like if we take Delhi, for
Yeah.
instance, and as you taught us segmentation, so we could divide the whole state into different areas, and we could first analyze what are the different purchase intentions, like in North Delhi, East Delhi, South, and West separately, and then according to that, we can decide which stores to put up and how the store.
Are you from Delhi by any chance?
Yes, sir. Gurgaon.
Yeah. Now you will understand. You can better understand rather that within South Delhi there are so many pockets.
Right.
Say if I take just GK2 or Nehru Place, and
Yeah.
just adjacent to that there is Govindpuri, Okla.
Right.
They are
Yes.
diametrically opposite. So do you think that will work? And you will find lot of areas in North Delhi or even West, I should just say, West Delhi are very similar to the areas that I just referred. So,
But sir, again, it works according to the different purchase intentions. Like,
can you please be a bit closer to your microphone? I'm having a hard time.
yes, sir. Is it fine now?
Not really. Anyway, go ahead.
Yes, sir. That was all.
So no, that's not the right strategy. Well, just dividing east, west, south, north will not help for the simple reason that within South, as I mentioned to you, there are so many pockets. So many East Delhi, North Delhi, West Delhi lies within South Delhi by going by your logic.
Okay. Okay.
Right.
Right.
Say, for example, the Tughlaqabad area, that's very much in South Delhi, but that is very much, has got very much similar to your Patel Nagar or all the West Delhi parts. Govindpuri, Okla, entire part, even the Jasola part, they're not that developed like your GK2 or Saket of South Delhi or Basant Kunj or Basant Vihar of South Delhi, right?
So do we need to check the income density of people, like checking the neighbor who is?
I like your thoughts. You are saying Aishwarya, right?
Yeah.
Okay, you said land price income.
Well, lease.
But tell me something. Land price is still you can get, but how can you get the income distribution of a particular area? Isn't it? Isn't it difficult? You are theoretically correct. But say if I tell you, you just give me the income distribution of GK2, just take the example of Varnika of Delhi or any particular locality for that matter. It's not that easy, right? Theoretically, you are correct. Yeah, that's true. but who is going to disclose the income? And you're going to get that income distribution of a locality. Very tough. So let me tell you, in the interest of time, let me tell you, I got such a project very recently from one of the leading retailers of the country in India only. And you know what we did? We banked on the satellite image data. And that's the latest thing in retail analytics. From the satellite image data, we can understand what all you mentioned, like density of population, how many malls are there, how many movie halls are there, how many footfalls are there in the movie halls. So everything on a real time. When, at what point of time people are going out, when the crowd is picking up. So everything you can get from satellite image data. So that's the latest one. You can have all the variables that you are thinking of, you can get it on a real time from this kind of data. So you have to think this creatively. I shall come to such kind of image analytics part in this slide only. But yeah, think creatively. This is something, I'm covering the entire spectrum of retail in this slide, like buy, move, sell, marketing, and enablers, like demand forecasting, inventory allocation, which we call it inventory optimization. If you have done supply chain management, you must have done this inventory optimization part. You must have done supply chain analytics, right, in your term 1 or 2 in the first year, right? So all this economic order quantity, how much
No,
to
sir. We haven't.
supply chain, you were in second year, correct?
Yes,
Or-
sir.
And supply chain has been taught or not been taught to you in the first year?
No, sir. Actually, the basic like inventory EOQ has been taught,
Okay,
but not like analytics.
that's fine. That's fine. At least you know what is inventory optimization in that case. For the simple reason, inventory optimize. You know what is the meaning of the word optimization? How many of you know the word optimization? Because I shall keep using that word like storage optimization. Everybody is optimization. Do you know the meaning of the word optimization? Have you studied operations research as a subject?
Yes, sir.
Perfect. Then all of you have studied, right?
I don't think so, sir. But
Okay.
some of them would have studied in the UG.
Let me tell you. Okay, there's UG separate, but in this course, let me tell you in one word, you will understand. There are many scenarios. There are many scenarios where we cannot neither want to maximize nor want to minimize. You cannot, rather, because of several constraints are there. So for those constraints, you need to come out with such a number which is between the maximum and minimum. That is what we call the optimization. Let me give you with an example of this inventory only. Suppose you want in your retail store, every customer should get all the products what they are looking for in the store. So what you have to do? You have to keep a huge inventory at your store. Now that requires space. That means that requires cost. So that is the kind of maximization. You cannot afford to keep all the inventories in your store. That's why there are warehouses. So that is the maximization. Minimization, you shouldn't keep anything. That is not possible. So you have to come out with a kind of optimum number of products in the shelf so that the most of the customers get what they want. So that's the kind of optimization. Say store hours optimization. You cannot keep it open 24/7 or the other way around, the minimum. So that's a kind of optimization, that window where most of the customers will come. So that's the optimization part. Is the concept of optimization clear to everyone? Like price optimization. What is the right price so that the maximum sales will take place? Space optimization. How I cannot allocate maximum, I cannot allocate minimum. What is the right amount of space, so that I can create the maximum sales happen? Say route optimization. What does that mean? It should be such being drawn that I can cover the maximum stores. Say transportation analytics you are doing. You are running a kind of logistics company that will deliver the products at multiple stores. So it should be, the truck should follow such a route that it will cover the maximum stores at the minimum amount of fuel cost. Am I making sense with the word optimization?
Yes, sir.
Yes, sir.
Yes, sir.
That's a very important concept. And we do it through the linear programming, non-linear programming, integer programming. These are different methods. which been mostly been taught in the operations research subject. And what I was discussing with the satellite image is a geospatial analytics. That's what we did recently. Anyway, let's come. I shall not, in the interest of time, I shall not spend much time what has been taught earlier. Like demand forecasting is a very important part of retailers, and what we do, forecast each SKU in each store and in each distribution center on a daily, weekly basis. So again, for another store, we did it. For a leading pizza chain, we did it, and you'll be surprised to know. This is mostly you know, so I'm just giving it here like demand forecasting through classical statistics. I've done it yesterday. This I'm going to discuss machine learning and deep learning. But anyway, let me come back to the example. So I was developing a sales prediction model for a leading pizza chain. So what was important to know, what kind of variables should we take? I could have asked the question, but let me give you the answers. Like variables could be as diverse as the traffic through the street adjoining to the store. If actually such pizza outlets are in most of the multiplexes in the malls. So what kind of movies are going to be released in every week, every Friday, or in the weekend, and what is their probability of success of the movies? Because if the movies are really going to be super hit or super liked, then naturally the footfalls will be more, the sales of pizza will be more. So they have not thought, our client has not thought about all those kind of diverse variables, which actually leave an impact. When he did the model, he found out, yes, they leave a significant impact. But as a data scientist, as I mentioned to you, that you have to think very creatively. And we actually developed secondary models, tertiary models, like movie success prediction model, even to predict the demand of the pizza. And that was again interesting. And then such models are also been sold to other industry. Once that model gets developed as a secondary or tertiary, you can again sell it to the models to the different OTT players who are very eager to purchase the rights of the movies. So that's what business is. Again, you have to be business savvy if you need data science. Anyway, coming back to this particular slide, Arima got this XGBoost, LST, what you don't know is this bilateral regression. You can study this by yourself, but let me give you a kind of quick understanding of what this stuff is. So regression, based on the cross-sectional data, like why on cross-section means at single point of time. Sales is taking place because of several other variables. So that's the regression. And then you also know about the time series data, right? At time T1, T2, T3, T4, there is a kind of series across the time, like from yesterday we did, like from 1999 to 2004, every month data. Now, say for example, you will get data sets in demand forecasting scenarios where you will have both the cross-sectional and the longitudinal. What does that mean? You will get all the cross-sectional data across the time frames. So in such scenarios, you have to use the panel data regression, where you will predict in the cross-section and also see that how with the time the independent variables vary, independent variables impact change, and then you can figure out the impact on the dependent variable. So I'm not again going into these details, but yeah, very interesting variables like store opening time, local weather, public holidays, they all leave an impact on the demand forecast. But so you have to really think diversely. So local weather, for instance, I was doing a product in demand forecasting for a yogurt product in London. And weather matters a lot for such kind of products. Even yesterday when I was discussing about that Mexico's that fertilizer forecasting, weather matters a lot. So you have to think. Even public holidays matter a lot in case of retail store prediction. Okay, in the interest of time, I'm skipping the benefits part. This is something again a very important part. Planogram is, let me not ask you, let me tell you, planogram is a very important part in retail in the sense that will tell you very precisely that what products to be kept in what shelf, so that consumers' attention is being hooked or being grabbed by such kind of product assortment, and then your revenue gets maximized, your sales gets maximized. So that's the planogram part. So a lot of steps are there. I'm not going to details, but I shall come to straight away to the to the analytics part of it. The analytics part of it lies in many ways. One is, of course, the space optimization, as I mentioned to you. What is the space of every shelf? So what products should you keep in every shelf so that it should also look aesthetically nice? That means the different color combinations, different SKUs. It will also increase the revenue. It should also grab the consumer's attention such that they will be prone to pick those things. So a lot of interesting variables fit into your model. And then a lot of strategies are there, like say for example category upselling strategies. So if you want to upsell through your product assortment, you can even do that thing through your planogram development. So you have to keep those products for upsell and cross sell within that particular category. Category means, if you don't know, category means they all the products in a category should serve similar purpose. Say for example, the beauty products, the bathing products, or the home care products are different categories. So what are the different products within the categories, and within that you can do a kind of lot of upselling, cross-selling, planogram aesthetics, and these are all you have to define in terms of variables. Mind it, that's very interesting. In fact, whatever you see in the retail store, they all can be converted in a variables. Apparently, they are all qualitative things like the ambience. Ambience can be the lighting, can be the visual merchandising with the mannequins and their props, can be the store layout. Store layout is definitely space optimization. That's a very, very, very important part. Um Even the temperature, the music, why not? Yeah. So all those factors help in making the sales happen. So why not to convert them in a creative way to the variables, and then put it into your model and see that which particular is the best scenario, the happy path to make the sales happen. Am I making sense to you guys? Yes, no?
Yes, sir.
Okay. So key benefits I'm skipping. This is pure analytics in the sense that you have to create the dashboards for the retail managers to take the decisions. Again, that we have developed for another leading retail chain who are into the space of these cotton products, uh, the towel, bed sheets, bed cover, bathrobe, like that, and we created interesting business intelligence dashboards for them with their software choices. Of their software was W, but yeah, you can do it through W, Power BI, ClickView, whatever you want. So what should the dashboards represent? What story should it come out? So the first one is the self-performance analysis. How are you self-performing to understand how a category is performing? So that's how you can reassort the products on a shelf. Self-replenishment. Replenishment means, you understand how quickly will refill, right? So self-replenishment, like uh, your day of supply, your profits, increase the profits by putting the high profit margin products at the eye level. So we have to think in a creative way that yes, this is my self-performance, this is the frequency to which I replenish the shelf, and everything comes in a kind of dashboard. Stock replenishment. Stock needs to be continuously ordered to ensure that the shelves appear fully stocked, and how we can automate the whole stuff. It doesn't happen like previous era. It is happening in an automated way now. The moment after a certain level, the products get sold out, automatically in an automated way, it goes, the order takes place. Assortment planning, what I'm continuously saying, that conducts store level assortment analysis to determine which planograms perform the best with new and discontinued items. That means what are the different varieties, the different variants of the products you will keep. What products, first of all, what products, even within a particular category, you will keep. And within that particular product, what are the different variants, different stock keeping units, SKUs you will keep, so that your sales becomes the maximum. basket analysis and profitability. Again, a very important concept, like what all products the customers are purchasing together. That's the kind of market basket analysis. So product A and B are being purchased together, or A, B, and C getting purchased together. So that's the kind of basket analysis. Then comes the product affinity. Determine new product affinities for co-merchandising and other incremental revenue opportunities, like which two products are being purchased together, improved category visibility, how you can track the category performance, determine the role of categories in driving the eye traffic. Is your category driving the eye traffic, margins, overall store growth? You have to understand all those things through the dashboards. So that's what can be developed. And again, a very important part is that how we are going to present the dashboards, right? The dashboard cannot, exist on one laptop or only one system for that matter. It should be hosted on the cloud and through web apps, through mobile apps, through Android, iOS. You have to present those dashboards. So that comes the uh, app presentation, and you can even remotely sitting at the headquarter, you can manage every shelf of every store of your chain through that app. And how is that possible? It is not only possible, it is not only through that data entry. These are the different app development technologies. That's fine. But this is a very important part I'm coming, is that it is not only about the entry of the data, even if it is auto entry, like from the sales of the uh, products in the store. You can find out that how many products lie in the shelf. That is not possible. So our common sense says what? Our common sense says that, oh, I can the sales head who is sitting maybe in the head office and managing the number of stores. If we just look at the sales figures, uh, then the sales manager can understand how many products are there on the shelf. That's what the common sense says, right? But that doesn't happen in reality. So products sold and products exist in the store does not give you a complete picture of the products that are lying on the shelf. Many a times it happened when we interacted with these retail stores, we understood that many a times it happened that the store persons are not that cognizant, and even if the products that has come down, that has almost been exhausted from the shelf, the store personnel has not taken enough care to replenish the shelf with the stocks that lie at the back end. So what is happening if you just rely on the data means the numerical data that is there in the system? You are seeing that, okay, this many amount of products has been sold and this many of products are there in the stock of the store. So your common sense will say then the remaining product must be on the shelf. But that's a myth. Am I making sense? Yes, no, tell me. Always give me the feedback, because I cannot see your faces. You can see me, but I can't see you. So are you understanding what I'm saying?
So how does this AI-based store operations happens in e-commerce industry, especially in Amazon, Flipkart, warehouses, and their
That is the easiest part. That is the easiest. Even in the offline, I'm coming, but I have not started discussing that part. You asked me, or rather answer me, what I have told you just now. Have you understood the dilemma or not understood?
yes, sir. That part will get.
Can you or any of me give a quick feedback? The last dilemma that I mentioned. What is the gap that I mentioned? What is the gap? Any of you? I just discussed a gap, a huge gap. What happened? So that
So
means you're not okay, right?
stocks replenished by the store employee from the store. Even if the stock is exhausted, he's not replacing with the original. From the backend store.
You're absolutely correct. You're Aishwarya, right?
Yeah.
Yeah. Now there comes the application of AI part. So what we have done is that we have installed these kind of cameras within the store, and those cameras are taking the images of the shelf on a real-time basis and creating the auto alerts if the stocks on a shelf are coming down. And it's not that easy because the software behind the camera has to be smart enough. And there comes your AI analytics part, like to identify, say, this is a shoe, and to be more precisely, it's the kind of athlete shoe. This is not a boot. This is not a floater. That your model should be smart enough. For that purpose, we use convolution neural network. The model should be smart enough to understand that. So it identifies the stocks on the shelf in an automated way from the camera without relying heavily, without banking on the data entered by the store operators and anybody for that matter. Anybody means not only the sales manager, even the sales director, even the marketing director, even the chairman of the company. Everybody can have a complete visibility of each shelf. Not only visibility, but also they have got the access and the right to manage what they are seeing and what kind of strategy needs to be taken. So these strategies are taken in a real-time way. Strategies can be what category should be pushed up, what should be the assortment to make the cross-sell, upsell happen, uh, when to order what product at what price. Of course, there's a kind of price engine we plugged in at the back end, the order engine at the back end, everything has been plugged in. But that is something, beauty that we are bringing in the modern retail world. They are all being managed through this image analytics part, the AI part. Am I making sense to you guys, what I'm saying?
Yes, sir.
Great, great. Now, I should ask the question about the AI in the this kind of online retailers that I already discussed with you, right? That is the easiest, because there you are playing only with data, not the offline space. Offline it is more difficult. So when I mentioned in the online about the recommendation engine, uh, you are doing segmentation on the fly. That's the AI in marketing. On the fly segmentation, on the fly targeting. On the fly means the real time recommendation engine for YouTube, Netflix, whatever you are doing, even in Amazon for that matter. They're all AI based, right? It couldn't be possible. Couldn't be possible by the traditional way to do the entire model development and execution done on a real time basis. You log into YouTube, you log into Netflix, any of these, online platform, they will show you the right products and right services to you the moment you enter. That's AI. That's so very smart. That's absolutely smart. Yeah. So that the other technology that I applied for another, US-based clients, that's Beacon Analytics. Again, something very interesting. I don't know how many of you have heard about this Beacon Analytics or not. Before I come here, let me sum it up. So what new things you have learned? The first thing in retail analytics you learned today when I discussed about the location, about the satellite image data. Then you learned here about the stored image data, how to analyze that. This is the third interesting thing, besides the dashboards and the planogram part or the optimization part. The third interesting thing is about the beacon analytics data. So what happens here is that, so smartphone captures the beacon signals and distance can be estimated by measuring the received signal strength index, RSSI. The closer the receptive devices, the stronger will be the signals. And PC, mobile phones, tablets with the BLE support can all function as beacons. Like what happens? Retail beacons sends a unique signal. Customer smartphone pick up the signal. Retailer app, which is beacon enabled on the phone, sends signal to the online platform. The platform tells the app to perform an action. The app formats information of the customer, and the customer receives the targeted personalized messages. So you are, for example, driving on a main street, and then you have got the app of that particular retail chain, and customer knows, the retailer knows very well that the customer is searching for the particular product in the store. From the past behavior, we mind that thing, what the customer is looking. And what we do is that we can, send the targeted messages, personalized messages. That's again a very important. And personalized messages, don't think that this personalized has been done by a human being. We do, which is technically called mass customization. Mass customization we do, and that too on the fly, real time. For every customer, personalized messages are being created. Personalized promotions are being created. Underlying technology, again, you have already learned, by the way, not that these things are absolutely new to you. What is the underlying technology? All your propensity modeling, uplift modeling, target marketing that you have learned. Yeah, the philosophy remains the same. The modeling techniques may vary. Maybe I have shown you logistic regression what we are using is deep learning, much more sophisticated, but the philosophy remains the same. The idea remains the same behind it. So that's what the most of the things are where the retail industry is heading towards. Every customer is unique. Every customer is unique to the retail store, and how the retail store's objective or the holy grail is to understand every customer's demand, every customer's profile in an in-depth way, and then customize the offering to every customer in a unique way. As what is the result? The benefit is that the customer will feel, yes, this retailer is meant for me. This retailer is meant for me, and everybody will feel the retailer is meant for me because you are actually developing the personalized messages, personalized targeting strategy, personalized marketing for every customer, and all these technologies. So when I discussed about the satellite image, why should I do that thing? It is location means, is it just where to open the store, where not to open the store? Not like that. It is about, even if I have to take a decision to open, say, 1,000 stores across one metropolitan cities, or 500 stores, or 200 stores, whatever is the number, then can I or should I use the same strategy in every location? Not really. How I should customize my 4Ps, 7Ps, the people, process, physical evidence, of course, product, price, plus promotion, everything as per that location. So that is the kind of customization and the mass customization where the industry is heading towards, and that is only possible. It is only possible with this technology. Without technology, it would have never been possible. And whatever this planogram, this entire and the steps that we have shown to you, it's all been automated nowadays. Automatically transforms in-store pictures into planograms. The planogram software are there, and the planogram software are fed by this automation software. Planogram software is fed by the demand forecasting engine. So that becomes the input data. So if the details, so that's kind of huge engines run behind what you were seeing even in the offline chains. That's the point here. So you can see certain products are there. You enter a store, certain products are there. What are the kind of different engines that run? So demand forecasting engine generates the demand for every day, every week, every season, every month. And then based on the demand, the planogram engine generates the right planogram for the day, and then showcases that. Of course, inventory optimization engine works at the back end, which ensures that the right inventory must be presented for that particular day. And then entire network optimization for the warehouses at the back end, the transportation analytics, replenishment analytics. All these engines contribute to make the store operate seamlessly. That's how the entire retail store management works. I hope you got some flavor, right? You got some flavor of how retail analytics work.
Yes, sir.
Any questions? Any questions? So if you don't have any question, there is what you can do to get your knowledge updated. You can do a few readings. Of course, I shall share few reading materials, but then you can also do your own search. The first thing you can do is that satellite image analytics for retail stores, and you will find a lot of papers up there. Then you can do the planogram automation for retail store. How the planograms been developed traditionally? What are the planogram software? How the planogram softwares work? What is the space optimization within a planogram? Do your study on that way. Then comes the retail business intelligence or retail descriptive analytics or simply retail analytics, where you will find all these sales performance, sale for stock replenishment, assortment planning, basket analysis. This will come in the retail analytics space. How you can do the mobile shelf management, Google it is parts. So my point is that you study each of these streams separately, and each of these streams itself is a kind of, will give you a lot of knowledge. And then you come to the image analytics part, in-store image analytics, how the in-store image analytics helps in the store operations, stores inventory management. This is a very critical diagram. Try to understand it in as much detail as possible. There is a lot of depth to this one slide itself. How the classification algorithm work. Any questions? Somebody said something, I guess. Okay. And then lastly, you study that use case of beacon analytics. How does beacon analytics work? And then you can, if folks who are really want to do something new, besides the traditional jobs, can take any of this use case and then develop their own product, own platform, and they can sell it to the leading retailers, and that would be rewarded like anything. So if you can develop your own engine of image classification, and then that could be plugged in through a planogram, that's a kind of interesting business opportunity. AI powered planogram, if you are creating, or if you are creating a kind of beacon analytics for some of the retailers here in India, that's a kind of huge opportunity. So that's again another roadmap you can always take to be an entrepreneur and develop some of your products, platforms, which would be most appreciated and rewarded financially as well. That's the roadmap.
Sir, wouldn't it be very costly for retailers in India to apply these kind of analytics in their stores?
Well, the question, let me modify it in this way. Nobody looks at the cost in isolation. They of course look at the cost, but nobody looks at cost in isolation. Everybody, even for this project also, when we came, the cost was definitely not something, a peanut. Cost was definitely substantial. But what every businessman looks is that
ROI.
Exactly. Now, let's find that, the cost of keeping this camera and developing this software engine behind it, that cost, even if it cost a few crores, that cost is much less than the cost of the revenue lost when my customers come to the store and my shelves are empty. There is a space cost to it. There is a store personnel cost to it. There are lost customer cost to it. You add all those costs are far higher than this hardware and software cost.
Okay, sir.
That's a good question. Any other question? Okay, so these are all the beginning. Every class is the beginning of your journey. It is definitely not can be the end of the class, but it all depends on you, that how you can take this knowledge forward, and there lies the entire difference. So yeah, all the best. Have a great day and see how you can manifest the most out of the knowledge of this class. Thank you.
Thank you, sir. Thank you, sir.
Welcome. Bye.
Thank you, sir.
Thank you. Bye.